All right. So let me set the same thing that I said here. Start with my same thing. I don't put it in the bit. But you exercise phase of the program, you have to do the phase one before I do it. That way you learn from it. So I know the market was clear. You can see your own mistakes and learn from them. What you're supposed to do after you discover a mistake, you want to redo the session. So I'm recording the session so that while going back over the question that you got wrong, you can then go and look at it again and see what I said. You have to be eliminating mistakes. You have to be reducing the number of mistakes. Clarifying stuff now. Two things. The stuff at the same practice the paper, you're going to be stuck at the same level as you eliminate. Remember, there's going to come a point where you're going to test how well we are improving and how well we are not repeating mistakes. If you don't do these papers, I cannot test that. You can't know if you make progress or not if you don't do these papers. You have to do these papers that I give you. If you can't come on the Saturday, you can come and do it on Friday evening. You can't come Saturday to do the mock exam for whatever reason. You can come Friday evening. You can't come Friday evening, you can't come Saturday. I'm very sad. Because it means then that you won't be able, you won't get the level of preparation that I want to have for the exam. I want it to be that when you go in the exam room on exam day, you can just relax and feel comfortable and feel like a familiar place. No stress at all. When you see the paper and you see the question, you must feel as if you have done all these questions before. That is how it must feel here. And it has to be such that any question on that exam paper that you find difficult, you don't worry about it. Because it means that kill the rest of the Caribbean. That's what it means. Any question on the exam paper that gives you problem, it means that that same question is killing everybody else. Because we would have exposed ourselves to every kind of question at every level. You have to do your part. You have to come do the work. You have to come and do the work. You can't come do the work. You have to do the paper still. I send the papers in the group. You have to do the paper. You have to do the paper before I do it. Leading up to March, leading up to this exam preparation phase, it was okay for you to do the questions after I do them. Yeah, in the phase now where you have to do them before I do it. And when I do it now, I say, yes, I'm good with that. I'm comfortable with that. Because the whole aim, or a primary aim of all of this, is for you to know what you don't know. You have to know what you don't know. When you know what you don't know, you go after gaining the knowledge of those things. You can't know what you don't know, you just come and watch me do the solution. Because I will always be explaining what I'm doing. And you will understand it. But doing it on your own is a different thing. You're going to have to do the exam paper on your own. First, I listen to the question. You have to practice for that. Right? You have to practice for that by doing papers, as many of them as possible. You have to participate in the program fully. You have to participate in the program fully, especially this last year. Even if you're not participating fully in the first part, because the second field, you play lacrosse, you play swimming, or whatever it is that kept you from participating. That's why I'm deliberate wait till champs done to start this. I'm always wait till champs done and everybody knows can be locked in and participate fully in the process. you can gain the maximum marks available for you to gain. It don't make no sense you have the potential to get a 1 with straight A's and get a grade 2. I get a 1 with an AAB. No make no sense. If you have the potential for 1 with straight A's, that is what you must get. And if the potential is not there yet for 1 with straight A's, we gain it in the class by what we do to build the potential up to that level. And this is a program that is preparing you for 1 with straight A's because we cover all the bases. I would far more than any other program, I can tell you that for sure. When other places they're doing 2 mock exams or 1 mock exam, we are doing 24. When other places doing 5 multiple choice, we are doing 30. No joke. You cannot act ordinary. We want extraordinary results. And we want extraordinary results. So we have to do extraordinary preparation, we have to do extraordinary work. No want ordinary results around here, so. Leave ordinary results to other people. We want extraordinary results. 1 with straight A's and people that make performance list. And that me I talk about. And I mean, I said, they're exposed to a program like this and not get ordinary results like everybody else. What it said? It said, man, you know, the other program, now go on, like, oh, we are going to this program. But what? This program. Because we want extraordinary results. And I can't approach it halfway. You know, approach it halfway. I'm not going halfway. Because the greatest joy is to see those results when exam results come. Everybody I get 1. Straight A. That's what we work towards. That's what we must get. We have to put in the work to get it. That's why I get a lot of 15 out of 3 results that are good for it. Then I'm taking one thing for this. Now, if you don't want to do it, just follow me and follow. You know this. Just do what I tell you now, and then we get the result. So I said, do the paper them, do them. Nothing in this program is arbitrary and random. Everything is to a plan. There's a reason for everything. The paper that they get, when they get it, there's a reason for it. Everything is planned out right down to the day before exam. Everything planned out. Come on, man, even if the mock exam, they want to start missing the mock exam. You can't miss the mock exam, you have to do the paper still. You have to do the paper and a time constraint. Exam, a time constraint thing. You do it on a time constraint. You have to practice under exam condition. That's what I want to come here and do. But when you're doing that home, you know what the time and the subject. You have to work comfortably, you stop for eat, you go bathroom and this and that. You listen to somebody over the top. I want exam condition. That's how we in here. I'm putting an exam condition. So an exam day comes, you feel in a familiar place. You know, you feel it's comfortable. Comfortable do the paper. Maximum possible mark than get on the paper. Maximum possible mark. You don't want to leave any mark in the exam room. And you want to discover all the possible mistakes you could make in the exam room. Make the mistake before the exam day. Don't make them on the exam day. You can't correct that again. You make the mistakes now by doing the mock exam, you can correct those mistakes and then not repeat them in the exam room. That's what it's about. Discovering your mistakes. That's very important to do all these papers, all of them. If you don't know, you have 4 papers per week, paper 2. 4. You have 2 for the weekend, Saturday. 1 way you do here, 1 way you do at home. You have 1 Wednesday and you have 1 Thursday. You are in the Thursday class. On Wednesday, you get 1 to do here. When you come here Thursday, you do 1 here in the room. So just 2 of them will do it. You have class 5 days a week now. 5 days a week we engage in this program now. 5 days. And those who can't come Saturday, come Friday to that, make it 6. What are the days? Sunday, Monday, Wednesday, Thursday, Saturday. 5 days. It's not no 2 days a week program anymore. It's 5 days. When you're not here, You have something to do at home. Wherever you're at. If you can't do it in that time, you have to find how much time to do it. You want success in the program, this is what it takes. All right. Remember, I have to talk about it again, please. Get serious, man. Get serious. Here. The pass market will grow, you know. There's going to come a point when the pass market is 70% and 80%. I want to say 70 and 80. That mean. If you not get 70 and 80% when you're supposed to get it, it means that that's a true reflection of what you're going to get in the actual exam. Some 35 and things we're at now, just for us to build, find out mistakes, eliminate them. So we start with 70 and 80% pass mark we want, and that we want to get. So we build to it. We're not there yet. So let's go. Do the market exam. Participate fully in the program. I will start off a marathon, revision marathon, and I'm going to participate too. Them free. I charge, you know. I'm going to everything. We have some marathon classes. One marathon like 4 hours. You're going to make it 4 hours. Nature C is 4 hours. Each of the topic them 4 hours. So it might be that you come to Saturday class in the morning, do the mock exam, and you have the marathon session in the evening. CMD. That's what we have to do. Do the mock exam in the morning, then we have a transformation session in the evening, like for 4 hours. And we have to use up the Easter holiday. No, Easter break, you know. Forget about that, you know. No, Easter break, you know. Oh. Forget about Easter this year, you know. I exam here this, you know. No, Easter break, you know. Forget about that. All right. Ready, let's go. Let's work through this paper. 9 is the paper, this one. 26. All right, ready. First question is the calculator question as usual, right here. It says use a calculator to work this out. If the answer is a fraction, you're blessed. You have a calculator that can type this in exactly as it is. All right? So let's do that. Learn to use the calculator. Improve on your calculator now, ma'am. Improve on it now. Yeah, learn to use the calculator. If you don't use the calculator, come check me. Show you how to enter the figures in the calculator, all right? But top calculator. That's a mixed number base, a mixed number. Class is 3 and 3/8 minus another mixed number, 2 1/4. And then dividing that by another mixed number, 1 1/2. And that's 0.75, which is 3 over 4, don't it? Equals 3 over 4. Get your mark and go about your business. Next question, please. 3 over 4. This one wants us to give this one correct to 2 decimal places. Work this out. 2 decimal places. Clear the calculator. Type this in the calculator exactly as it appears there. Bracket 2.86 plus 0.75. Close bracket plus 0.481 squared. That gives us 3.84136. Question said 1 decimal place, 2 decimal places. So the correct is 2 decimal places. So these are the 2 decimal places. I'm going to use this one to correct those 2 decimal place values. That's 84 right there. 1 can't change 84. 1 too small. So it becomes 3.84. Just check that we're typing here the same thing. Let's do one more double check. Yes, it is the same thing. So we're good to go. But I got at that. 3.84. I'm going to stop talking. Next question. We have a consumer arithmetic question. It says Paul bought and sold a computer. Price how much you got it for. It's how much you got it for. The product price, that's when you money, 13.99. That is the mark price. That's the price. Then the discount on the market price is 5%. Counting it at 5% means that we're selling it at 95% of the mark price. That is taking off 5%. It means that we're selling it at 95% of the mark price. You don't need to calculate 5% if you don't need it. Question said, what is the selling price? Selling price is 95% of this. Mark price is the price of the mark money goods for sale. So when you go in there, you negotiate the man and say, boy, I want it less than that. Man say, okay, we have 5% discount because you pay the cap. You're selling it at 95% of the mark price. But understand that. Good. So the discount is 5%. Basically, the selling price is 95%. So you can say selling price is 95% times the mark price of 13.99. But understand we'll get 95% from 5% from 100%. 100% would be the mark price, 13.99. But you're not selling it at 100%. You're selling it at 5% less because you're giving a 5% discount. So you're selling it at 95%. Some people calculate 5%, then subtract it and all of that. You don't need to do that. Waste of time. Learn to manipulate percentages like this. So let's work out 95%. 95%. That's figure. 13.99. So he's selling it at 1329.05. That's the selling price. That's what he's selling at the amount of money that you get. He's selling out. All right. Then it says no, calculate the profit or loss as a percentage of the cost price. So the one that it's a profit, actually a profit, right? Because he's selling it more than the cost price. The cost price was this, and he's selling it for that, he's selling it for more, he's making a profit. The percentage profit, therefore, is the profit over the cost as a percentage of multiplied by our own, so we get as a percentage. Right? The percentage profit, that's what a percentage profit. Equal the profit over the original cost multiplied by 100. That's what you do. Express as a percentage. What is the profit? The profit is the difference between the selling price and the cost price. That is the profit. So it is the 1329.05 minus the $1064 divided by the cost, which was 1054. 1064. 1054, yes. And then you multiply that by 100. Express it as a percentage. Or something. Multiply it by 100. And do that calculation. And you say, with a fraction, the profit is 1329.05. I don't need to show the actual profit. Don't need to show it. Don't need to get the answer. 1064 by the cost of 1064. And you multiply that by 100. So it's like 25%, 25.91%. Three significant figures will be 24.9%. That's a percentage profit. Very good. All right, beautiful. Next question. Better buy. Orange juice is sold in cartons of 3 different sizes. Carton this cost that one. 450 carton is for that. 500 milliliter carton is for that. Which size is the most effective buy, or which size is better buy? Which one better to buy? Which one give you more value for money? We can do this by seeing which juice you get more of for $1. We bring them treat like a ratio and bring the money down to $1 and see how much juice you're getting for $1. That's an easy way to do it. You can also do it by seeing how much you're paying for 1 milliliter. That's another way to do it. One that you pay less for 1 milliliter is the better buy. But let's do the $1 method. The one that you get more juice for $1 is better buy. So let's do it. To get $1 here, we're going to divide by 4.2. We divide this by 4.2 and see how much you're getting for $1. That becomes $1. We have to divide it by 4.2 as well. Divide it by 4.2 as well. Or 4.20 if you like. You're gonna put the amount here for that is for the 4.2. For the $1. So it's 350 divided by 4.2. 83.3 milliliter. Let's write it here. 83.3 milliliter. That's for $1. Second one. Want this to become $1 divided by 5.35. Divide this by 5.35 to get the $1. Now if they divide by the same amount, 5.35, divide this also by the same 5.35. So like a ratio, you divide the value by the same value. You divide that by the 5.35, that's 450. Divided by 5.35, get 84. So that one I better already. 84.1. So this one is already better than that one, right? So it was just these two alone. It should be the better one. I get more for $1. Let's look at the last one. 580. 580 of $1 divided by 5.80. 5.8. That becomes $1. If we divide by the same amount, 5.8, divided by 5.8 as well. I'm going to put the comes over here. Getting for $1 for that. So it's 500 divided by 5.8. Which is 86.2 milliliter. So there you go. Third one is the better buy. Voila. Getting more juice for $1. That. And I can leave these on my table as my calculation. I can leave it there if you want to do it down here, so no problem. But I can leave that as my calculation on my table there. I'm going to tell him now that the 500 ml carton is the better buy. The most effective buy, I'm saying better buy. Same thing. Why? It is more for your $1. More for $1. More for each $1. That's it. That's it. So the third one is a better buy. But to go to that, beautiful. Easy question. Bring it to $1. First question down, the bottom of the 11 one. Huh? Good. Next question. Factorize these things. But this one has a difference of 2 squares, you know. It's a common factor. If the difference of 2 squares factor, do the common factor first. Factorize the common factor first. 4. You're going to get 4 into a squared minus 4. Common factor first. Then that's the difference of 2 squares. But it can be written as 4 into a squared minus 2 squared. Then that's the difference of 2 squared. The difference of the numbers and the sum of the numbers. That becomes 4 into a minus 2, a plus 2. And no part of this can be factorized any further. Therefore, it has been factorized completely. But good? That is it. That is it. Look here, if you get this, if you get 2a minus 4 times 2a plus 4, that's wrong. That's not factorized completely. But this part can be factorized with a 2, And this part you have a factorize with a 2. Get me? Completely means none of the factors you have a factorize any further. That's what factorize completely means. All right, that is that. Next question. I try to know me how to factorize. Quadratic. Factorize. Let's practice the process again. This is the factorize when one of the coefficients are prime, you know. Like this 3y squared. The only factors of 3y squared is 3y and y, you know. So you can literally figure out the other two factors of this 8 to finish it quickly, you know. Because this is the prime. The only two factors of 3y squared is. You want to tell it? Trial and error. Trial and error can become a method, and you basically can look at it and factorize it quickly in the head. So let's go to the one first. Now, so the process is always to multiply the two n coefficients 3 times 50 at negative 24. Now, factor of negative 24 that add to this middle term of 2 on the 2. So our factors of a negative number, one factor of positive, one factor of the negative. If a larger factor, the same sign as this sum that they want them to be. The first two factors of 24, I know say 6 and 4 already. Let's say never. Go down the list of factors till you find. You go 1 and 24, the larger one positive, smaller one negative. Those two add 23. Who you want? You don't want it. Next two factor of 24 is 2 and 12. Larger one positive, smaller one negative. These add to 10. You don't want 10. Next two factor will be 3 and 8. Larger one positive, smaller one negative. These add to 5. No, it's 2 you want. Don't want that. Next two factors is 4 and 6. Larger one positive, smaller one negative. These add to 2. Yes. We're going to break this 2y into these minus 4y and plus 6y. Or you can put 6y minus 4y. Right? That's how it is. Ready now. So this thing, we're going to come and split it down here. So this 3y squared comes back. 3y squared. And this 2y, let's say, becomes 6y minus 4y. Let's just put out that here. Plus 6y minus 4y. Always say that we just split into here. We give back the middle term, which it does. Then we have minus 8. Minus 8. Then we have created 4 terms we can factorize by parts. So you factorize in the first 2 and factorize in the second 2. Factorize by parts. The highest common factor in the first 2, not the common factor in the highest common factor. 3y. You factorize the 3y. Out of this, you get a y. Out of this, you get a plus 2. What do we say? Y plus 2 must be a factor from these two as well. That kind of makes sense. We'll put it back from now. Y plus 2. It's okay. What comes in between here? Either plus a value or minus a value. Not just a value. This case, it is a negative 4. Because if you look from this and divide out the y, you're left with a negative 4. Or you get the number as well. Negative 8 divided by this 2 give a negative 4. So the factor out here is negative 4. When this is like your common factor now, your y plus 2, they have been added to y. Factorize it into y minus 4. So this and this. The common factor of y plus 4. That is it. All right. Leave it like that. But good. All right. This says now where to solve this pure simultaneous equation. We're going to use that elimination method. This has a minus 2y. This has a y. I'm going to adjust this one and make this about 2y as well. That's the elimination method. So this one, I'm going to multiply by 2 to get this to become a 2y. Multiply each value by 2. So then it becomes 4x plus 2y equals. This one I don't need to change it. So this one stays as it is. It stays 5x minus 2y equals 12. But these have different signs. We can add the two equations, add up everything together. We're like you're adding up everything on this side, and you're adding up everything on this side. So we're adding the two equations, but that will eliminate the y for us when we add the two equations. Right? So the 4x and the 4y, the 4x and the 5x is 9x. This one is add up to give you 0, the y portion is other. And on the right side, this one is giving 8. And to divide by the 9 now, you get x equals 2. One value. What that x is equal to 2, you're going to take 2 and substitute, for example, the first equation right here. You see what the y is. So we can just simply say, and 2 times 3 plus y is equal to 3. That's from this equation we use it. Draw like that for an example. Huh? 2 times 2 times 2 times 2. That's a 4, don't it? 4 subtract over the to give me negative 1. So y equals negative 1. You can do a quick check in this to see if it works. 5 times 2 minus 2 times negative 2. Yeah, that equals 12. So it's at 10 and it's at 2. That equals 10. You know, so the answer them good. Next question, please. These are the answers. You can write the solution line. X equals 2, y equals minus 1 are your answer. That's it. But all right? Nice and easy. Next question. Part C said, table below shows corresponding values of two variables, x and y, where y varies directly as just x. That means y equals k times x. Direct variation is a times variation. Inverse variation is a k over. The direct is k times. Inverse is k over. This is direct. So the first variable is k times the second variable. You have a scrape on the x and a scrape on the y and a straight on the straight x and y. So it means then that y is equal to k times x. Now this question asking for the p and the u. This is an example. You don't need to calculate the k. You don't need the absolute value of the k. What do we realize? If you divide by the x here, you realize that the k is equal to y over x. K is equal to y over x. You have to calculate that. You have to calculate the value of k. What this means is that the y over x is always equal to a constant value. You want to calculate the k, fine. You don't need to calculate the k. You can work it from here. Y over x, for all of these pairs is the same. That's what that is basically saying. Y over x with a pair here equal y over x with a pair here equal y over x with a pair here. We can let whichever one set it up. Let's do the first pair. This and this. So the y over the x. Y over x is a constant, right? So it means that the 3 over 6 equals u over 10. Understand that? Because the k is always equal to that. Y value over the x value on all the pairs. Find the u, we'll just take this 6 and multiply it up here. So this tells us that the u becomes 10 times 3 over 6. 3 over 6 is a half. So the u equals 5. In fact, you can look at it and see that this value is always half of that value. That's what it is. This is 10, this is 5. This is 9, this is 4.5. This is 4.5. No, 9, this is 18. This is always half of it. You can do the other pair. K again equals this y over this x. 3 over 6 equals this y over this x equals 9 over the t. I try to make you the subject. You can multiply the t up here. The t equals, take this 6, multiply it up here, and take this 3 and divide it. The t equals 9 times 6 over 3. It is 18. That is it. If you do it the way we find the k, fine, but you don't need to find the k if they don't ask for the k. Let's realize what the K equals. In this case, the constant is the Y value over the X value. So for all the pairs, Y over the X for one pair equal Y over the X for the next pair equal Y over the X for the next pair. So you can use that and do. All right. If you find the method of finding the K, in this case, the K would have be half. You can use it as well. All right. That question done. Easy question. Next one. Let's do the sets question. Question says, when the below shows the number of students who study history and French in a class of 30 students. I'm going to put 30 right here so I don't forget. The total in the Venn diagram is 30. All these subsets must add up to 30. All right? So H are the ones who study history, F are the ones who study French. Use the universal set of the class. So write an expression in terms of X, the simplest form for the total number of students in the class. That's all of these added together in the class. And just want an expression. So and I said put it in simplest form. So it's 18 minus X plus X plus 14 minus X plus 5. I.e. All right, one final expression now. Other value like values. So the 18 and the 14 is how much? 32 plus 5. That's 37, right? That's correct. 37 is the number. And then this minus X, what about this X? I have this minus X here. There's 37 minus X represents the total in the class. 37 minus this expression. Total in the class. I'm trying to put an equal expression, right? That represents the total in the class. Then it says, state whether the following relations are true or false. Let's state if they're true or false. H union F is equal to the universal set. Is that true? No, because H union F is just linear. It does not include this. This is the part of the universal set. But this statement is false. That's not true. But understand that. Because H union F is just all the people inside here. The universal set is everybody. It is not true that H union F is equal to you. Universal. But this one no. H intersect F complement. See this? This means inside of H and outside of H. It actually means H only. That's what that means. H only. This is referred to this. H minus X. Right? Unless X equals 8, this what the value of X is. What the value of X. Total equals 30. So X equals 7. What can I say that X equals 7? If 37 minus X is 30, then X equals 7, right? 37 minus 30. Total is 30 right here. You have to equal to 30. The X was equal 7. This is 18, this. But not true, because this is actually equal to 18 minus X. So this also is false. This is also false. You see, this means null set. This means empty, right? But know that, right? But the symbol for empty are null set. Another symbol for empty set is just this. The two brackets like that, right? Means the same as this, a null set. Empty set. That's not empty. But H only is 18 minus X, well, X is 7, so this is also false. So it's false and false. We're going to have a class where we do pair sets. We're going to have a class where we do pair sets. We might do it after the paper 2. So that is coming on the paper 1. I'm trying it before the paper 2. But if you don't do it before the paper 2, you definitely do it before the paper 1. That's it for coming on the paper 1. All right? This one says, determine the number of students who study both. That's X amount, you know. We say i.e. X. They're asking us for X. X equals 7 pairs of 37 minus X is 30. X equals 7. This is actually asking us for X. That's for the both French and history. That's in the intersection of French and history. That's it. That's it. Got good? All right. X equals 7. That answer is 7. Done. Fast to do this construction. Let's sketch it before we construct it. Always sketch it before you construct it. It's asking us to construct a triangle PQR. PQ is 5. Let's sketch it. PQ is 5. The angle at Q here is 60 degrees, like so. And the angle at P is 90. Oh, sketch it before you construct it, guys. That's what they want, right? That's what they want. So let's do the construction. Let's do the construction. Let's do the construction. We're constructing a 60 and a 90. Ready? Let's draw our 5 centimeter line first. Bring in the ruler. I want to draw a 5 centimeter line. Five centimeters. And at one end, we're going to use a compass over here, and we're going to construct 90 degrees. Remember now, the method we use to construct 90 degrees in this program is to construct a 60 and a 60 and bisect the second 60. The 30, 30. The first 60 and the 30 give you the 90. We're going to draw a big arc now for the 120. All the way over here, so we want 120. We move the point to here and cross that first arc at 60. Then you move the point to here in the intersection and make that second cross, second 60. So we now have 60 and 60. We're bisecting the second 60 now. Let's use a different color to bisect the second 60. Use blue. We'll come back at this end. Rotate it up here. I'm going to make an arc. Over this end, with other intersection. Cross that. That's going to be a 90. Let's construct the 60 degree down here now. Down at this point. Let's change the pen to red again. So down here, we're going to construct a 60 degree arc. On turn. Move the point to here. Rotate over and cross that one. That's a 60. Let's draw in the 90 now. Let's draw it in black. Straight line through here, through the intersection. That's a 90. Then draw the 60 now, through the intersection from this point, through the intersection next step. I don't want it to make here. That's it. This one need to go somewhere. Anyway, get the picture. Two of them are going to meet up here, so right? Two of them was going to meet up there. So we can extend this here. Something like that. They're going to get. And then down here is 5 centimeters. This is 60 degrees, this is 90 degrees. All right, that's a construction. Next part says, measure and state the length of PR. Oh, let's leave it up. Let's leave it up. This was PQR, right? This was PQR. Yeah, measure PR. It's off the page. But to measure PR, we basically use the ruler over here. We use the ruler over here. Measure this length PR. The ruler from 0, measure it down, like about 8.6 or something. How much are we going to calculate? You don't want to measure of angle PRQ at 30 degrees. That's actually 30 degrees inside here. Just bring in your protractor, rotate it, put the eye on the point up here. Rotate it around. That 30 degrees. So this answer is 30 degrees. But this one I could calculate. Let's calculate the answer what's supposed to be. Because we can. To be tan. To be tan of 60. Equals PR over 5. So PR is equal to 5 tan of 60 degrees. You're not supposed to calculate, I'm doing it, you know. I can put the measure it. I'm calculating the check. There's 5 tan 60. 5. That's 8.6. 8.6. I put 8.7. 8.7. Measure. All right, that's done. Next question. Silver box. So I call it silver box. Paper box. The silver box. Question says, diagram below not drawn to scale shows a silver box with no lid. Sides and bottom of the box, 1 centimeter, 1.5 centimeter thick. This is the thickness right here. 1.5 all around the box. Sides and bottom, even the bottom, 1.5 centimeter thick. Calculate the volume of the box using the external dimensions. External measurement at the 20, 15, and the 30. What else than that? At the external volume of the box. Let's call it E external. From 30 times 20 times 15. What I work out to? What do I get for that? Nobody did it? Huh? 9,000 cm3. Good. But this one is at 300. Number 30. All right, let's go. Next part says, complete each of the following statement. Internal length of the box is 30 minus 2 times 1.5. Why is it minus 2 times 1.5? Good, the thickness out here. So they're talking about is internal dimension here. So they're talking about. We did a question like this recently. This internal dimension between these two. The full 30 minus the 1.5 over here. Right. Minus this little thickness of 1.5. And this little thickness of 1.5. That's why you get 30 minus 1.5 on the inside. So that 30 minus 3 is 27. The internal dimension inside here so is 27. 27. So let's put the 27 down here. C equals 27. Let's do one for you. Next one. The internal width of the box. That's similar thing you have to do. The width was what? It was 20 externally. And subtracting 0.5 on this end, 1.5 on each end again. 1.5, 1.5, subtract the internal width of the box. So 20 minus 2 times 1.5. Understand that? Comes 20 centimeters minus 2 times 1.5 centimeters. That's it. 20 minus 70 centimeters. Understand that? Then know the depth of the box. You want to subtract 1.5 alone. Thickness at the bottom, right? The overall height of the box is 15. We only have this 1.5 thickness at the bottom down here. So it's 15 minus 1.5 is the internal depth of the box. 15 minus 1.5. Here, 15 centimeters minus 1 alone of the 1.5. That's equal amount. 13.5, right? 13.5 centimeters. So these are the internal dimensions of the box. Internal dimensions. Those three give it the internal volume. Calculate the internal volume of the box. Those three you have to multiply. The internal equals 27 times, what was the second one again? 17 and 13.5. Equals, let them keep the work out. Somebody tell me. 27 times 17 times 13.5. What can help me? 6,196.5 cm cube. Internal volume. But my silver is the difference between these two now, don't it? This minus this. The volume of silver material that make up the box. Right? Question now said. The box is made of silver, which has a mass of 10.5 grams per each cm cube. Calculate the mass of silver in the box in kilograms. So the first thing we need to do is calculate the volume of the whole box. The silver. The volume of silver. Volume of silver equals the internal volume minus the internal volume. That's 9,000. We're sold to go. Nah, nobody's helping me. Give me digits. How much? 2, give me digits. 2803.5 cm cube. Now, 1 cm cube is this. So to get this amount in grams, we have to do multiply it by this amount. But after that, all this means, this statement right here means that 1 cm cube of silver is equivalent to 10.5 grams. So if this is the amount of silver really, we have to multiply by the same 10.5 to get the amount in grams, don't it? So this amount is equivalent to 28035.5 times 10.5 grams. And then I want it in kilograms. So if I get 10 grams, I have to divide by 1,000 to get it in kilograms, right?
Yes, sir.
Good. So this becomes, you cannot divide it by, you have to divide it by 1,000 to get it in kilograms. That's right. Divide by 1,000.
Sir,
Yes.
will be 29.4.
29.4. That's it. Kilogram. What do I get that? That's what y'all got. That's correct. Three significant figures. 29.4 kilograms. That's beautiful. That question done. 11 marks. Next question, please. Number 5. Diagram below not drawn to scale shows two straight lines, JK and JL, intersecting parallel lines. So once you have straight lines intersecting parallel lines, you know you have some Z angles, some U angles, and some corresponding angles taking place, don't it? So for example, since these two lines are parallel, they are both crossed this straight line, means that this 100 and this 100 is the same, don't it? Corresponding, don't it? It also means that you have some Z angles in the place, right? So for example, we'll come up this one, along the parallel side, alternate on the other side, is that this 100 and this 100 is the same as well, as Z angles. Then we also have some U angles taking place, don't it? Right, we also have some U angles taking place. So for example, now, these two angles are co-interior angles. This and this. I like to have a down this one, come back along here, like you have a U. These two angles add up to 180 degrees. Let's identify those things in these diagrams, right? All right, that's what I want us to do. Question says, we are to tell them the value of X and Y, and Z, or and W. I must give reason, right? The X first. How's the total on a straight line is 180 to get X, don't it? And you're not going to put any degree on the X. But notice it says X degrees. Notice it says X degrees. X is just a value. Don't put any degrees on it. So the X is just equal to 180 minus 128, don't it? That's 60, 52, that, don't it? 52, X equals 52. Why is that? Total angle, hey, getting noisy. Total angle on a straight line is 180 degrees. That's what we use, right? So this angle is 52 degrees. Then these two angles are used, well, them two are corresponding now. This and it's corresponding now, don't it? Don't it?
Yes,
Two of them relate to this parallel line the same way. The straight line relate to the parallel line the same way. So those are corresponding angles. So the y is just equal to 128. So the y is equal to 128. This is because corresponding angles are equal. Good. Next one I want is angle W. Let's look at it. Angle W. The angle W is right up inside here. All right. Watch this now. Multiple ways to do it. Multiple ways to do it. I can, since I know this angle here, I know this angle is 83 now. Why is that angle 80? Because of the U, see? Bam, bam, bam. U angles. Co-interior. So these two angles add up to 180. This angle down here says 80 right now. This angle is 80 degrees. That's not the only way to do it, eh? Multiple ways to do it. And I can focus on this big triangle. And I have two angles in it. And what I do is the W, don't it? So W is 180 minus these two, that's all? Don't it? 180 minus these two. There are multiple ways to do it, guys. Multiple ways to do it. All right, 180 minus 2. All right, let's do it. So the W becomes 180 minus the 80 and the 52. So it becomes 100 minus 52 is 40, right? So 40. I will use total angle in that big triangle is 180 degrees. That's just 180. Total angle in that big triangle is 180 degrees. All right. That's not the only way to do it. There are several other ways to could have been. That done. Transformation. The angle below shows triangle RST and its image R prime, S prime, T prime after transformation. That looks like a translation. No turning, no change in size, no change in orientation. Translation. Just move from one place to another. It's on the same way. Just move from one place to another, right? And you give 1 point is so much it move by. This is 1 point, like from this to this. There's how many units left or right, how many is up or down, right? And you check the scale of the graph. Make sure say 1 centimeter is 1 unit, vertically and horizontally, yes. So you can count up units now. So horizontally is 2 units, don't it? Vertically, that's a +2. But vertically is a minus. 1, 2, 3, 4. -4, don't it? -4. There's a translation 2, -4. Don't it? 2, -4 translation. They're gonna ask you to describe it for sure. He said describe fully transformation of maps, a translation. Translation 2, -4. Can I get him that, you know? I can say 2 units to the right, 4 units downwards. 2 units to the right, 4 units downwards. 2 units to the right. And 4 units downward. But I've said that as well. Then it says, no, the original triangle RST is reflecting line x equals 6. On the graph, draw the image triangle R double prime, S double prime, T double prime, the image of triangle RST after the reflection. We want to draw the coordinates of R double prime. So let's draw the line x equals 6 first. We can count out the reflection. So this one reflecting in line x, y equals 6. We draw the line in red. Y equals 6, x equals 6, right? X equals 6, the vertical line passing through. The 6 right here, so reflected in this line. That's x equals 6. 1 point at a time. S is 1 unit, S prime gonna be 1 unit on the other side right here. S double prime. This is 1, 2, 3, 4 units. It is gonna go 4 into another side. 1, 2, 3, 4. It's coming to here. So that becomes R double prime. And this is same 4 units. It's coming under here. E double prime. That is the triangle. I want us to write the coordinate of R double prime, don't it? That is 10, 3. 10, 3, right? This point is 10, 3. R double prime is 10, 3. 10, 3. But I give it that? 10, 3. That question done. You can pass. But the most pass 35 marks already. Let's go. Next question. Coordinate geometry when I give you the line. Easy. You can get everything off the graph. Diagram shows the graph of the line x plus y equals 3. Yes, cross y x at 3, cross x at 3. That's x plus y equals 3. So determine the equation of a line which is parallel to this one and pass through the origin. It's going to be x plus y equals 0. But after that, the parallel to it and go like so. It's going to be x plus y equals 0. That's all. So that the x plus y line and it pass through the origin. So it's x plus y equals 0, don't it? With the mathematics easy. Remember the x plus y line, I'm always go like so, you know. And cross the x-axis and y-axis at the same place. So they're parallel to x plus y line, then it's x plus y line. All x plus y lines are parallel. And the one of them want pass to 0. That pass to the origin. So x plus y equals 0. Come on, keep it simple. X plus y equals 0. That pass through the origin. 0, 0. X plus y equals 0. Right, go. Next one. It says perpendicular to x plus y equals 0. And pass to the midpoint of the pass to right here, so. This is 3, 3. Midpoint must be 1.5, 1.5, don't it? And it's perpendicular to it. Maybe like this. What's the equation of that line? Pass through the origin and pass 2 points where x and y values here. Y equals x. Them somewhere in the work, you know. So y equals x. Right? You see this line? It has a gradient of -1. So the perpendicular line to it must have a gradient of 1. And the pass through a point 1.5, 1.5. Pass through a point with the x and y values here. And it has a gradient of 1. So it must be the line y equals x. Y equals x. Y equals x. Yeah, the mathematics are y equals x. See it? That's the beauty about the graph, because you can see it. And then, y equals x. That's what it is. All right? Next question. Function y equals x squared minus 2x minus 3 is a quadratic. A small shape quadratic. It has a line of symmetry and an axis of symmetry. Or axis of symmetry and a vertex. Table is for x values between those points. And they have missed out that value and this value. The values are symmetrical. So for example, this 0 is between the 5 and the minus 3. This must be 0 as well. See that? So the values are symmetrical. This must be 0. Come on, we do much like big people now. The values are symmetrical. Inward toward the line of symmetry. These values are symmetrical. If you want these x values have the same interval, y value is going to be symmetrical about a line of symmetry. The line of symmetry, or the symmetry is right here. That's a symmetry. That becomes the vertex. After symmetry, x equals 1. This going to that axis of symmetry. The axis of symmetry is where x equals 1 right here. So all you have to get the y value there is plug the 1. Plug the 1 in this function to get the y value right here now. Let's work it out. The y value right here, plug the 1 in this. It's going to be 1 squared minus 2 times 1 minus 3. That's -4. It's y value is -4. The vertex, that vertex. Vertex is the turning point, the minimum turning point. But understand that? All right. Complete the table by inserting missing values. Done. That's the table complete. You want to get the 0, you get the 3 and plug it in the function as well. It's going to work out to be 0. It's a waste of time. We have to learn the symmetric nature of these functions because of the function, the values. So this is really the turning point, you know. 1, -4. That's a minimum turning point. 1, -4. Question says, on the same axis using part A, that's on the previous question. Draw the graph. This draw the graph. Same axis over here. I want to steam man. I want to draw the graph. We want different graph. Let's draw it on this. It says 1, -4 is the turning point down here. What are some of the values? The axis is right on this. So if you find any value of 5, you can use the axis to find the other one. That's the axis of symmetry. That's the turning point. Pick another point. So these values are Negative 305. Negative 305 on the left. Negative 3 right here. Here, here. 5 up here. Those are the values. Okay? On the right, the same thing. Negative 305 on the right. 305 on the right of that. Negative 305. Those are the points. They're gonna smooth curve through those points. I'm talking to the top. They're gonna smooth curve through those points now. The positive there. Turn down here. That's it. That's a sketch of your graph. One thing else I wanted to do, draw the graph, right? Use the information from your graph. You must take the minimum value. Minimum value is the lowest y value. It occurs at x equals 1 at the vertex. X equals 1 right here. See here, so? At x equals 1. See? At x equals 1 right here. That's the vertex point. Minimum point is at x equals 1. Now, what's the minimum value? Did they ask for it? Nope. So the value of x for which this equals this. This is where the line and the curve intersect. Which represents the line. Remember the line was x plus y equals 3. Y equals minus x plus 3. That's what this is. This is the line. And this is the curve. Right after that? So this means where the curve. Asking for where the curve equals to the line. The curve. Curve is the line. You want where they meet. Here. Curve is equal to the line. What's the x value right here? X value right here is negative 2. X equals negative 2. Right here, so x equals 3. Equals 3. What? Like to ask you a question. Look here. Anytime let's see them give you a graph. Two different geometric objects. Before for the question, ask you where they meet. Some kind of format. The question is always where they point where they meet. They meet at x equals minus 2 and x equals 3. That's it. Minus 2 and 3. X equals minus 2, x equals 3. Meaning they plug minus 2 into this equation, two sides going to equal the same value. And if you plug 3 in this equation, there's two sides again going to equal the same value. All right, that is it. 3. Minus 2 and 3. Question done. Next question. Number 7, statistics. Remember, guys, you have a mock exam on Wednesday. You have a paper on Wednesday. I have a paper on Thursday. If you want to come here, come do the paper Wednesday, fine. Right? Those who can't come, I'm going to send it in the group. Make sure you do it. And Thursday, I'm going to be here. 5 to 10 parts. Right here. And then Saturday, I have 2 papers again. Come on, man, no joke. 20 bags of sugar are weight. Weight to the nearest kilogram are as follows. These are the weights. I want us to do a tally. The tally of counting off. Right? Roll by roll. You know, check it. Knock off. This one has to get supposed to be. This complicated supposed to be 30 here. This is supposed to be 10 here. Here. 38 is in this. 33 is in this. 33 is in this. 28 is in this. 12 is in this. 43 is in this. 38 is in this. 31 is in this. 30 is in this. 11 is in this. 8 is in this. 23 is in this. 18 is in this one. 26 is in this. 50 is in the last one. 22 is in this one, so I'm crossing 25. 35 is in this one, crosses as well. 39 again in this one. 5 is in the first one. So that's done. Tally, pick and pass. Good. It is 3, it is 4, it is 5, it is 6, it is 2. It's not out of the third. You can check it. Out of the third. Yes, out of the third. Because them 2 are 10. Out of the 20, sorry. Them 2 are 10. Then 3 are another 10. All right. We're good to go. That's it. Next part says, for the class interval 21 to 30, they're talking about this class interval. The question's talking about this class interval, right? What is the upper class boundary? The boundaries are the values which that can go to. This proof can go from 20.5 up to 30.5. The upper boundary is 30.5. 30.5 kilograms is the unit of measure as well. 30.5 is the upper boundary. 30.5. Next one, the class width. Class width is going to be 10 on Western. Because all these values going up by 10. So I know the class width is 10. But class width is upper boundary minus lower boundary. Don't go subtract the 30 minus the 21. It's going to be wrong. Boundary is how wide values, how wide the values that can go, how wide are the values that can go in the group. Values can go in the group from 20.5 up to 30.5. 20.5 is the lower boundary. 20.5. Anything 20.5 or more can go in this group. Anything less than 30.5 can go in that group. The boundary is from 20.5 to 30.5. 10. Don't put 30 minus 21 and get 9. That's wrong. It's upper boundary minus lower boundary. Mama, we get these things right in the game. We made a mistake. Correcting those mistakes now. All right? Correcting those mistakes now. There's going to be upper boundary 30.5 minus lower boundary 20.5. That is 10 kilograms. But I'm saying you can also know it's 10. Because all these values increasing by 10. Lower limit increasing by 10. Upper limit increasing by 10. That's how these questions are always set up. Everything else is kind of symmetrical in terms of the width or wide the data is. Right? It's 10 kilograms. The midpoint is the average of the values. Then the average boundary values, I can do the average limit value. Same average of the value. The midpoint. So it's 21 plus 30 divided by 2. If you want 20.5 plus 30.5 divided by 2, answer is going to be the same. That becomes 51 over 2, which is the amount. 51 over 2 is 25, 25.5, that 25.5, 25.5 kilograms. That is it. Next part says, on the grid on page 19, you just see a 2 centimeter with 10 kilograms on the x-axis, 1 centimeter with 1 bag on the y-axis. Draw a histogram. Bars of histogram move from boundary value to boundary value. Remember that. Bars of histogram go from boundary value to boundary value. And for continuous data, so there are no gaps in the bars. All right? Remember that. Page 19. Oh my God. Oh, please, man, keep missing. All right. Let me get a graph for this. There's a graph on the 20. There's a graph on the 20. Let me get the 20. Oh, there's a graph. Go there. That's it. There you go. There's a graph. Tell you. Oh, the man. Spending that. Two centimeters to 10. 2 centimeters to 10. Let's go. 10, 20, 30, 40, go 50. The ball go on a 0.5 then, remember. 2.5 then. The farmers go on 10.5 and 0.5. The lower boundary is 0.5. We're starting at 0.5 here. Starting at 0.5 up to 10.5. We go to all the 0.5 until you reach 50.5. That's what it goes. Upper boundary for this one is 60.5. Starting at 0.5 and 50.5. Now look here now. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we get the 0.5 then right. Let's put the 0.5 in blue. So the 0.5 is here. The 0.5 is here. See that? You can literally mark all the 0.5 from now. You may enjoy the bars on those 0.5. Everything important. The bars of histogram go from boundary value to boundary value. So the bars going on those blue marks. We should draw them up to the right frequency now. So the frequency scale is supposed to be what? Frequency scale is 1 to 1. 1 to 1. I want them on the back here again, but it's I want to lower it 1 centimeter to 1. And lower it. All right, 2 centimeters is 10 kilograms. And 1 centimeter to 1 bar. Yeah. Is the 1, not following the 1 centimeter. It was the 1, 2, 3, but it's gonna look low. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Blue. Right. Next bar goes up to 4. We continue this up to 4. This one goes up to 4 right here. This one goes up to 5. Bring this up to 5. Next bar over here goes up to 5. Here. This one goes up to 6. Bar goes up to 6 right here. As of Instagram group from boundary value. Like 6. Then it drops down to 2. The last bar drops down to 2. 2 right here, so this is 2 line. Right here, so drops down to 2. 1, 2. Moving to the 3. Good. You know, the last one is down to 0. 2. That is your histogram. Bars of histogram go from boundary value to boundary value. That if I do a boundary value, learn. Good. I want to know space on the bar. Histogram. Continuous measurement data. All right. Next one. Dot. Question dot. That is it. Next question. Next question is grade pattern question. I can tell you what happened to a student of mine this year. He spent a lot of time in the exam trying to work with a formula. I know formula was required for this one. Look, then I asked me no formula, then I asked me none. And there were only 10 shapes. So if you can't figure out a formula and it's only 10 shapes, just one of them. Give 10. Like that. It's only 10. Then I figure one again. I figure 53. I figure 23. Just 10 plus. So if you can't figure out a formula to do it, it's one of them up to 10. One of 10. Be smart. Understand? If you can't a formula, will give a formula. This one never asks for a formula. 1. And 2, it was only 10. You're going to work out the pattern, work out the values of the 10. Get me? Let's go. First thing is to draw figure 4. What can I say, right? And then keep adding mistake and mistake. Don't see. Don't it? Adding it on each and each curve. And I don't give a stick, right? This thing is being added to each state, right? So added 1 dot and 2 sticks. For every dot, there are 2 sticks, right? Except in the first shape, don't you? Except in the first shape. Every dot, there are 2 sticks. Except for the first shape. The first shape. Every dot, there are 2 sticks. Every dot is accompanied with 2 sticks. See there, that you have 2 sticks. That you have 2 sticks. That you have 2 sticks. You can see that as a pattern. Except the first. Anyway, then the diagram below shows the first 3 figures in a sequence. Each figure is made up of knots and strings. Knots and strings. Each knot connects exactly 3 strings. What is that? That's what they keep adding. Someone draw the 4th one. Draw the 4th one, if you draw the 3rd one first, and then add on some knot. And here, right? Note it. That's what you have to do for the 4th one, note it?
Yes, sir.
Note it. I'm using that set manager because I have it. That's what's going to complete it. Copy it down. I'm sorry. You can't do that. But to make it easier for the exam nowadays, they start at this for you. Just ask them to complete. That's what the game is. Make it easy for you guys. All of this, that is my problem. Read. You got to keep There you go. Figure 4. You can pass. After this, of technology. Well, go to that. All right, ready now. Table now. Table below shows the number of knots and strings in each figure used to draw figure 1, 2, and 3. Complete the table by inserting the missing values in rows numbered 1, 2, and 3. And there's no formula row there. We still do a formula. What is happening with these, right? Is that basically you're adding 2 strings in terms of the knots? All right. That once again doubling the number of knots each time. Because you added 2 here, so. And then after you added those 2, you then added 4, right? And then you go and add 8. That's a knot. You keep adding 5 as many as the time before, right? That is the case, guys. You keep multiplying by 3. There's a 2 to the n relationship. Learn. 2 to the n is in here, so 2 to the power n. Right? Keep multiplying by 3. You have 1 that's first, and you add 2. That's twice as much. Then you add twice as much again. Then you add twice as much again. So you can forward 2 to the n to be in here. Let's test it. 2 to the n. I'm going to say, okay, yeah, 2 to the n in this formula. To the formula for the 2 to the n. 2 to the n. In the formula. Now we've got the first figure. First figure was 1, right? You can 2 to the 1 is 2, and we'll subtract that 1. Test it and see if it works on the other one. Yes, sir. 2 squared is 4. 4 minus 1 is 3. Voila, good. Let's test the next one. 2 cubed is 9. No, 2 cubed is 8. Aha. 8 minus 1 is 7. Good. The formula works. Yes. This formula works. This formula works. But I can't say that. Don't it? Watch this. That's the key, right? Please watch that. Let's talk about the S. Look, S now, there are two strings for every knot. And this represents the number of knots, don't it? Don't it? This represents the number of knots. There are 2 strings for every knot. But just that there was an additional string in the first diagram, don't it? You see here then, the formula here then is 3 times number of strings here. Number of strings is 2 times the number of knots, 8, plus 1 in the first phase. Plus 1 in the first phase. That's the formula for the number of strings. You can check it. 2 times 2, 3 is 6, plus 1 makes 7. Good. Test this. 2, 7 is 14, plus 1 makes 15. Good. That's the formula. Get a formula. Good. Now, if you never know, then you would have to just keep going up until you reach 10, until you reach 255, until you reach 10. You just have to continue the pattern. You're adding, for the next shape, you're adding twice this number of knots. And then 2 times that number of strings. And the number of knots where you add, you're adding twice as many strings to what you have. That's right. Continue that. What I would do in exam if I didn't get a formula. Just be down here, so reach 4, then continue in these figures. Just continue right down to 8. I'm adding twice as many knots as I did before. But each knot that I add 10 knots, I get 8 knots, and after I add 8 knots, I add 15 knots. That's twice as many. When I had 16 now, but I had 32 still. And after I had 16 now, that I had now 32 not the next time. When I had 32 now, I had 64 still. Every number that you add, you're adding 2 still. Right? If adding 2 because that you're adding it to the end of the still, you're adding twice as many as you did the previous time. And I would do that in the exam if I were you to get a formula. I would do that in the 10 years. Better do that for and waste time or try to get a formula. But learn though, guys. When you see a pattern, we keep multiplying by twice as you did before. There's a multiplying effect of 2. Then the formula has a 2. Multiply by 2 a number of times. Multiply by 2 a number of times. 2 to the end 4. Somewhere in the formula. 2 to the end, 2 to the end minus 1. But that's the formula, guys. I'm going to use the formula. 4. Put the 4 on that. 2 to the 4 power 16. 16 minus 1 is 16. Why is that? Because they would have added 8 more knots the next time. That's what we did to get the next year. We get stage 4. Added 4 knots, 8 more knots. This is 15. That's a plus 8. Next one would have to be a plus 16. The next one would have to be a plus 33. Plus 33. Next one would have to be a plus 64. Plus 128. If I was in an exam, that's what I would do to get my marks. Adding twice as many. And then if I add 32, that's plus 32 over here, so plus 50 over here, so plus 128 over here, so and so on. That's how I would get my students. I was in the exam and I couldn't figure out a formula. I would just add up all of them. It's only 10 sheets they're going to. That's what I would do if I were you. I couldn't figure out a formula. And then 4 number, I got the 15 number. I got the 15 on this. And the case of 15, 2 times 15 is 30, 31. 31. Why? Because I have to add 16 to this. I have to add 16 to this. Then I want 255. I want to know the K for 255. So now put this equal to 255. Right here. Right here, I'm going to say B times K plus 1 equals 255. 2K equals 254. 254 divided by 2 is a 254 divided by 2 is a huh? 127? 127. But this K now is 127. See that? This now is equal to 127. Right here now, all of the K is 127. This is 127. I'm trying to find the end. So here now, n minus 1 equals 127. 2 to the n is equal to 120 and 27. 2 to the n is 126. N equals what? If someone say I have to multiply by 2 to the 126, n equals what? How many times have you multiplied 2 to get that? How many times? 2 times, 2 times, 2 times, 2, 3, 5. The first, it's a right there. One centimeter, I guess. Hold on. Oh, it's 1 centimeter. Sorry, 1 centimeter. You're adding 1. My mistake. You're adding 1, not subtracting. 1 centimeter. 1 centimeter. 1 centimeter. 1 centimeter. That is 1, 2, 3, 4, 5, 6, 7. 2 to the 74. N equals 7. equals 7. After that, this is 150 we try to it. Here's 150. And then for 10, take 10 and drop it in here. So 2 to the 10 power right here. From 2 to the 10 power minus 1. 2 to the 10 power is a month. Work out in the calculator. 2 to the 10 power minus 1. How much is that? 1024 minus 1, right? 1023. What is the one? 2 times that plus 1. 2 times right here before. Right here now before. 2 times 1, 0, 2, 3, plus 1. This is one, right? That's 204.7. That's it. I'll put these in the That's it. Question done. Next question. Number 9. Give us 2 functions. That's the number 2. That's the function on the first one, f minus 1. Let's start by saying f equals 2 minus 7. Inverse that x equals 2f minus 1 minus 7. And this is the subject. So over the 7, add it and then divide under the 2. You have x plus 7 over 2. That is your f to the minus 1 of x. It's putting off x now. Are you good at that? That is it. Are you good? And this one, g equals x squared plus 1. I can put that together. So g equals x squared plus 1. I really think you will listen to that. What's that thing? I like inverse. I will calculate because I'm going to take the plus. Right? The inverse, if we get x equals g to the minus 1 squared plus 1. You want to make this subject. Subtract the 1 and then square root. Subtract the 1 and then square root. We get square root of x minus 1. That is g to the minus 1 of x. But after that, we're not taking the negative square. Let's take the positive square. Now this one now, f of g means g into f. Remember, it means g into f. Let's write them down. So the f, remember, is what? What's the f again? F is minus 7. The g is x squared plus 1, right? It means g into f. Means I'm putting all of the g. I put it into the f where the x is right here. So put g into f. So f of g of x is construct 2 times all of the g going where the x was. X squared plus 1 minus 7. That's 55. That's 2x squared. 2 times 1 is 2. And 2 minus 7 is negative 5. That is that. Very good. 2x squared minus 5. Let's continue. Next one. Inverse of this. The one. No, inverse of this. So that we can actually calculate this by recognizing that this is equal to, look, this is equal to e to the minus 1 of f to the minus 1. Remember that? Inverse of a composite function. See that? We can form this by doing that. And put the f to the minus 1 that we have into the g to the minus 1. Let's write them down. What are they again? F to the minus 1 and the g to the minus 1. So we have the f to the minus 1 is this one. X plus 7 over 2. Let's write them down. Minus 1. X plus 7 over 2. 7. This means that we're putting the f to the minus 1 into the g to the minus 1. Right, this construct now, guys. Construct that composite the f to the minus 1. I'll put it into the g to the minus 1 where the x is right there. That's what we're doing. Construct it inverse. Remember, the inverse of a composite function is equal to the composite of the inverse. Remember, these order, that order is switched around. You notice? So that. Like, remember these things. So this then, when we do that construct, becomes equal to the square root, where this x is, I'm putting all of the f to the minus 1 there. X plus 7 over 2. And then this minus 1 beside it. Minus 1. Simplify this. The same as 2 over 2. This one is same as 2 over 2. 7 minus 2 is 5. So we form square root of x plus 5 all over 2. That's what it is. All right. This one now says so that this is equal to that. This at time. So that this is equal to this. Then I will work out this side. Work out this side and show that it's equal to the same. So this one, if you can obtain by putting the 5 in this, right? The FG all to the minus 1 of 5 means that we're putting 5 in this. And that's the FG to the minus 1 of x. It becomes the square root of 5 plus 5 over 2. That's 10 over 5, right? It becomes the square root of 5, right? Can I get that? And then we're doing this now. And g to the minus 1 of f to the minus 1 of 5 means that we're doing the f to the minus 1 of 5 first. It becomes g to the minus 1 of. Now, f to the minus 1 of 5 means that we're putting 5 in f to the minus 1 function. F to the minus 1 was this. You're putting 5 in that, right? It becomes 5 plus 7 over 2. So we get 5 plus 7 over 2. 5 plus 7 over 2. That works out to be 6. So we're doing g to the minus 1 of 6. And g to the minus 1 of 6 now means that we're putting 6 in this g to the minus 1 function. Right here where the x is. So it becomes equal to square root of 6 minus 1. Right, that better is for sure. Square root of 6 minus 1. We'll put the 6 inside here. In the g to the minus 1 where the x is. Put the 6 inside here. That becomes the square root of 5 as well. See, 12 equals square root of 5. See that? Therefore shown. 12 equals square root of 5. But good at that? But good? Use the stuff. This is a space-length distance time graph. But it's not meant to show distance traveled, it's meant to show how far you are from a starting point. Even though it named distance time graph, it's not meant to show distance traveled. It shows how far you are from a starting point or from a reference point. Mr. Todd, next said that the distance time graph below shows 3-stage journey of a car traveling from town A. Town C is 100 kilometers away. Town A is at 0. Good? Let's see what it says. Say the time of day at which the car arrived at town C. Let's look at this town C. Let's have to arrive at town C. You arrive at town C, right? It's like 8:30, don't it? Right between 8 and 9, don't it? 8:30 to arrive at town C. Again, town C when we reach town C, town C 100 kilometers away. It arrived right here, so that was it arrived, right? This is it arrived. So 8:30 a.m. 8:30. All right, 080. like this. 0.8, 0.830. 0.8.30. That's the time of day 3. Again, one more for that. Calculate the time, total time in minutes, the one, in minutes. For which car stop on the journey. Total time that it stop. Stop here, so here, so don't it? Don't it? Because at those 2 times, time is passing, but the distance is not passing, not changing. Time is passing, but the distance is not changing. So this stop was for how long? This stop was for 30 minutes, don't it? And this stop was for 15 minutes, don't it? Again, the stop for a total of 45 minutes. But agree with that? Yeah, for 30 minutes. The stop for 30 plus 15. 30 plus 15 minutes to stop for. That's 45 minutes to stop for. Stop for 45 minutes on the journey. Next part. Determine the constant speed of the car during stage 2. Speed on a distance time graph is gradient, or the distance over time. We're talking about stage 2. But the distance is covered in stage 2 over the time that it takes. All right, the speed. Let's look at it. So the distance is in kilometers and the time is in minutes. Let's see. Stage 2. Stage 2 is right here. This is stage 2. What's the distance covered in stage 2? Distance covered in stage 2 is 60 kilometers. But I get that? The time, how long is the time? From here to here. That looks like 1 hour. 30 minutes, 30 minutes. But I get that? 1 hour. But I get that? From 7:30 to 8:30. 7:30 to 8:30. That's 1 hour. So it's 60 kilometers per hour, don't it? 60 kilometers in 1 hour. I said it is. 60 kilometers in 1 hour. That's the speed. 60 kilometers in 1 hour. The 60 kilometers in 1 hour. Speed 60 kilometers per hour. That is speed. Kilometers divided by 1. Next one. Calculate the average speed of a car during time it was moving. Calculate the average speed of a car during the time it was moving. To get the average speed, total distance divided by the total moving time. Total distance we travel divided by the total time when it was moving. That's total moving speed. This average speed at the time when it is moving. That's what it is. Average speed when it is moving. So that is going to be equal to the total distance we travel divided by the total moving time. You don't want the total time, the total moving time. So question, what is the total distance we travel, guys? What's the total distance this string travel? Look at it. What's the total distance it travel? Up here, say I go 100 kilometers away. I go 100 kilometers to come back. So travel 200 kilometers. The total time it took was from 6 o'clock to 10 o'clock. That's 4 hours. We have to subtract the time when it stopped with 45 minutes. 45 minutes is 3/4 hour, don't it? So the total moving time is 3¼ hours. 3.25. But after that, the total distance is 200 kilometers. 100 kilometers go up there, so 100 kilometers come back. 200 kilometers travel. We have those not show distance travel. We will report that from. So how far it went from A. So 100 kilometers from A and then come back to A. Where so come back to it. The total travel distance is 200 kilometers. 100 away, 100 come back. Total time is 4 hours, but stop 45 minutes. The one is travel speed, time when it is moving. It was moving for 3.25 hours, don't it? And travel 200 kilometers. We're not going. Start soon on. Sit down. Don't get up. 100 plus 100 kilometers divided by moving time. 4 hours minus 0.75 hours. 0.75 hours is the time when it stopped, don't it? So the 45 minutes that it stopped. This works out now to 200 over 3.25. 200 kilometers over 3.25 hours. Give me final answer now. 61.5 kilometers per hour. But understand that? Huh? No, after that. So they give a distance. No, if you convert it to things, that's fine. Whenever ask for that. So if you give a distance in kilometers and give a time in hours, use them. Kilometers per hour. Yeah, but no. But it's not much. Not much. In physics, them say must go for the standard, right? SI unit. Too much. The distance in kilometers. Time in hours, kilometers per hour. Very good. All right, next question. Soon done, man. No, no. Your target. Let's go. Next question. Number 10. 2 questions left now. What I missed not next. Next question says diagram below not drawn to scale shows circle center O. EH and EF are tangents, so the 2 tangents from a single external point. Good. And the measure right here is 45 degrees. So it'll say over here, so 180 minus 45. Remember that, right? Remember that the 2 tangents, the 2 radii, form a cyclic quadrilateral. So this angle inside here, so is 180 minus 44, right? But remember these things. More things you know the better. Question said, can you give me for each answer angle EHF? Here that is. EHF right here. What happens is that remember these 2 tangents are equal in length. So this is an isometric, right? These 2 angles are the same, don't they? They are equal to 180 degrees minus 44 degrees divided by 2, don't they? Wait, that's 90 minus 22. That's 90 minus 20, 70. 70 minus 2 is 60 degrees. So that's going to be 68 degrees. Okay? Good. This angle is 68 degrees. Let's put the calculation here. There's 180 degrees minus 44 degrees divided by 2, 68 degrees is the answer. The reason for that is that that's an isosceles triangle. EHF is isosceles. EHF is isosceles. Number EHF is isosceles. That's why we do the 180 minus divided by 2. This angle is 68 degrees, right? That's 68. Next one. Angle FGH. Where is that? FGH. FGH. What are they equal to? What are they equal to? This one. FGH. And that angle is subtended by this chord. That chord is making an angle of 58 degrees with the tangent right now. The angle of 58 degrees, so tangent and chord root. And between a tangent and a chord, equals angle subtended by the chord. Come on, guys, you have to remember this thing. So 68 degrees, right? This angle up here is 68 degrees as well. Tangent and chord root. So this angle is 68 degrees. So angle between tangent and the chord equals angle subtended by the chord. We call it alternate segment rule in other places. Next one is angle JHE. Where is that now? JHE. JHE. That's 90 degrees, don't it? Tangent and radius is 90 degrees, don't it? 90 degrees. Tangent and a radius is 90 degrees. This one is 90 degrees. Angle between tangent and radius. 90 degrees. JGH. 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 That's a 90, so don't it? I'm subtended by a diameter, don't it? JGH. Right up here says 90 as well. I'm subtended by this diameter. That's 90 as well. That's easy question. 90 degrees. That's the subtended by a diameter. These are subtended by the diameter. That's why it is 90 degrees. It's subtended by a diameter. Something else? Done. Next question. Diagram below not Johnson scale shows two ships, R and S at anchor on a lake of calm waters. He said not move it. Stay one place. FT is a vertical tower. That's a vertical tower. It says FSR is a straight line. And RS right here is 150. Angle of elevation of T. Let's put them on. Oh, it's there. Angle of elevation of T from R and S are shown 22 degrees and 40 degrees respectively. What a question time. They tell you something and put it on the diagram. It says F is the foot of the tower. It's vertical and it's horizontal. So right here, 90 degrees. They're going to work in this triangle for sure. Because this is section 2 trigonometry. You know that. Remember, guys, remember something very important. This angle is the sum of these two. This angle inside here, sum of these two. The exterior angle of a triangle is equal to the sum of the two opposite interior. Right? Therefore, this angle up here, so is 40 degrees minus 23 degrees. That's 18, right? Good. Very important to know that. This angle up here says 18 degrees. Let's put it here. 18 degrees. What is it? 18 is right. 40, 23. 18 degrees. All right. This one in here is equal to the sum of those two. Remember that, guys. I set this set question with the same setup all the time. All right. Question says calculate 1 decimal place the measure of angle RTS. Where is that? RTS. Oh, is it just fine, don't it? Is it just fine? I'm going to set them off for that. Giving it away. 40 degrees minus 22 degrees. So now we're going to use sine rule in this triangle. These two with these two. See that? Sine rule. These two opposite angle and side that you know both of them. Sine rule. Length of ST. See it? We're trying to find ST right here. We're going to use sine rule. These two. So using sine rule. Let me leave it on the subject, you can see. Using sine rule. So ST over the sine of the angle opposite. ST over the sine of the 22 degrees equal the side that you know, which is 150, over sine of the angle opposite to it, which is the 18. What is that? You take this sine 22 and multiply it up here, you get the ST, don't it? I'll make this smaller now. So ST equals 150 times the sine of 22 degrees. Always put the trig behind the numbers, remember. Divided by the sine of 18 degrees. Let me calculate that one. Let's get it. So it's fraction 150 sine of 22 over sine of 18. That's 181.8. Let's say you want this small piece, you want this? 181.3. 181.3. What is it? Meters or kilometers? Meters. Not kilometers. It's done with 181.3. 181.3. Now we're working this triangle now and use so far door as a right angle triangle, right? This is the opposite to this angle. This is the hypotenuse in that triangle. That's for the height. We're gonna use sine equal opposite over hypotenuse. Sine equal opposite over hypotenuse to find the height of that tower. That is it. Find the height of the tower. We're gonna use sine in that triangle. But see that? Sine to find the FT. So we're gonna say sine of 40 degrees equals FT over the hypotenuse, which is 181.8. So the 181.8, I multiply it up here, that gives you FT. So we can write that. FT becomes 181.8 times the sine of 40 degrees. Work that out with the calculator now. 181.8 times the sine of 40. 116.9. 116.9 meters. Done. That's the height of that tower. Bam, bam, bam. One question to go. Let's finish strong. The position vectors of points A, B, and C relative to an origin O are these. OA, OB, and OC. The one, the vector AB, soft. O times the last minus O times the first. OB minus OA. What is that? So it's this one minus this one, not it? That's why we're equal to 6 minus 2 is 4. 1 minus a negative 2 is 3. But I get that? But I can say that? Yeah? Sure. All right. Just so you know. 1 minus a negative 2. That's why I'm going to get this 3. All right. Next question says AC. O times the last minus O times the first. So we're now doing this one minus this one, don't it? Equal, let's put it. 10 minus 2 is 8. 4 minus a negative 2 becomes 6. Don't it? This amount of this, you know. So 2 times that. Them two vectors are parallel, you know. And then we have a common point. So the points are collinear. Can you see that right away? Parallel vector with a common point. Hence determine whether A, B, and C are collinear. Yes. Because the bigger one, sorry, AC, is 2 times the smaller one, AB, don't it? And this means that they are collinear. Why? Let's write the conditions for collinearity. Put them over here in red. 1, them parallel, don't it? AC is parallel to AB. This means parallel. That's the first condition you need for collinear points. Parallel vectors. Second, you have a common point. A is a common point. That's why they are collinear. Therefore, A, B, and C are indeed collinear. Very good. Because you have that thing happening, right? I'm show it. 3 marks for it, you know. When I get the marks. Can't just say yes. You have to, see? So them say, give reasons for your answer. The reasons in that and these stating these things. You get me? Good. Next part says, that matrix is singular. Find the value of x. Stop talking, please. If it is singular, remember it has no inverse. So they could have said it has no inverse, don't it? And when it has no inverse, the determinant of the matrix is equal to 0. And when the determinant equals 0, the first diagonal product equals the second diagonal product, don't it? That's all. So we can say, therefore, the 3 times 4 is equal to 2 times x, don't it? This is 12. Now for that to be 12, x has to be 6. That's all. X equals 6. Very good. Soft with a capital T. Next one. N and P are 2 by 2 matrices. This one is the N, this one is the P. Determine NP, mean multiply them. I multiply matrices again. Root. 4, 1, 3, 2. 9, 1, 5, 1. If I use the rows of the first matrix and the columns of the second matrix to get the product of the dark kit equal. Let's work them out. When I get 4 values, put them in red. Show the word. 4 values of the dark kit. First value here is in the first row and the first column. So to get it to multiply this first row by this first column, multiply them the same way again. First element times first element. Second element times second element. First element in the row and the first element in the column. Second element in the row and the second element in the column. So it is 4 times 1 and 1 times 2. 4 times the 1 is 4. 1 times the 2 is 2. This value is positioned in the first second column. To get to multiply this first row by the second column. First element times first element, second element times second element. First element times first element, second element times second element. 4 times 5 and 1 times 1. 4 times 5 is 20. 1 times 1 is 1. This value here is positioned in the second row, first column. But to get it to multiply this second row with this first column. First element times first element, second element times second element. First element times first element, second element times second element. 3 times 1 and 2 times 2. 3 times 1 is 3. times P is 4. If the last value here is positioned in the second row, second column, they multiply this second row by this second column to get it. First element times first element, second element times second element, first element times first element, second element times second element. 3 times 5, 3 times 1. 3 times 5 is 15. 2 times 1. Final result. 6. That is 6. That is 21. That is 10. That is 7. One. One more for everybody. Next part. Given that P and in this, determine whether the base is complicated and it's not complicated. So we reverse them, the result is different, don't it? So, since En not equal to NP, matrix is modified and it's non-commutative. Matrix, right, it's non-commutative. It is non-commutative, which you all know, right? That is it. Right? Look at that. Right? Don't know. The term N minus 1 again. N is 4 1. What about the inverse of it? Remember the inverse 1 over the determinant of adjoint of right? Equal 1 over the determinant. This product or diagonal product and diagonal product. 4 to 8. Second diagonal product 1 times 3 multiplied by the adjoint. Interchange the elements on the first diagonal. Interchange them. 2, 4. Turn 4 to the 2, 4. Leave the element on the second diagonal where they are. Change the sign. This one becomes a -1. This becomes a -3. Write this 4 better. So now you're in 5, right? So this guy divided each of these divided by 5. The years of 5. Final vector, final matrix, sorry. 2 over 5. It becomes equal to 2 over 5 minus 1 over 5 minus 3 over 5 and 4 over 5. That is the matrix. Remember, if you're using the inverse going forward, using this one refraction with that, right? Over with this one refraction. It messed up. Here we want to use hence you don't want to use this result at the end of the day. I can find out xy from since n enough. N to minus 1 in front of this xy stuff, right? So I know that by here. This equation xy is going to be equal to the inverse of this matrix, which is n to the minus 1. But this matrix is really n, you know, n. So the n to the minus 1 go in front of the 1, 2. By the inverse by the 1, 2. As I said, I'm going to use this up here as my n to the minus 1. So it's 1 over 5, bracket 2 minus 1 minus 3 is 4 times the 1, 2. Same thing again. Rules by the 1 column. So we get 1 over 5 times the column vector. 2 values. This row times this column gives us this value first. This is 2 times 1 minus 1 times 2. 2 times 1 is 2. Minus 1 times 2. That becomes a 0. Then this value is this row times the 1 column. It's minus 3 times 1 and 4 times 2. Right? So minus 3 times 1 is negative 3. 4 times 3 is 3 plus 3. So that's a 5 and that's a 0. The final value here, that becomes a 0. That's a 5 divided by 5 is 1. That's xy equals that. So the final answer is that x equals 0, y equals 1. That is your answer. Better go to that. End of this test. And that is that. Is that. Right. See you all Wednesday. I'll do another mock exam on Wednesday. Those of you who want to come here Wednesday. Doing it at home. But the food is here. All right. All right, guys. See you. See you all on Wednesday. Wednesday and Thursday. All righty. All right, all right. I'm gonna end it now. All right. Everybody, I'm gonna end it now.